So there's an example on slide 17 of the lecture notes where we need to calculate the pressure drop in a bend of pipe. So I'm going to open up Citrix, and as frequently happens, I've got this warning that says I can't do something. I never know what that means, so I'll quit that and accept the fact that I can't do research with it on those machines. And I'm going to start up ease. Takes a little bit sometimes. All right. So now we're going to do I always give it a name. Pipe flow through an elbow, 45 degrees. Try to be as descriptive as possible. Okay, so now what do we know? Actually, you know what I'm going to do first? I'm going to save this right away. Save. And I want to save it on Box, right? Not actually on that computer. And then I've got nicely organized files here. 201, fall 2020, lectures, lectures week 6. Okay, and I'm going to call this pipe bend pressure drop. There we go. And this is a little bit slow because it goes through several layers of cloud and remote computing. All right. And there I went uploaded to Box. Okay, so the first thing we know, I know that the density of this particular water is rho equals 1, and then it's given to me in grams per centimeter cubed in the lecture. Times, I'm going to convert that though from grams per centimeter cubed. And I want to convert that to something in base units, so that's kilograms per meter cubed. All right. And then let's see, I also know the velocity U equals 12. And that's in feet per second. And then the bend loss coefficient, K equals 0.3. Now, if I came back and looked at this after the fact, I might not know what it is. So I'm going to say this is the density of the water, and then I'm going to put a comment here that says this is the velocity of the water, and then the K is the loss coefficient, so I don't forget what that is. Alright, so now let's just save this again. Should go a lot faster this time. And I'm going to do a check. Okay, I've got 3 equations and 3 variables. I'm going to check my units. No unit problems detected. And so I'm in pretty good shape, alright? So I could solve this. Oh, and I haven't done anything yet. Yeah, okay, because I've just entered my known constant, so let's get rid of that. The equation that I'm really interested in is delta P equals, and that's K times the density times the velocity squared divided by 2. Alright, and that's pipe loss equation. And actually, that's called minor losses from ME 363, fluid mechanics. Got to always pitch there. Alright, so now I added one more equation. Let's try that. 4 equations and 4 variables. I'm in good shape there. Let's check the units. Ooh. Okay, the dimensions of deltap, right, that's delta P actually, is dimensionless. I never gave that any units, so I've got to, okay, I forgot to do some important stuff. Alright, so I got to go up to this little window here, right, variable information up here. So the delta P should be in PSI, and then the K is dimensionless, so I just call that a dim, and then U is in feet per second. Feet per second, okay. Alright, so now I can check that. 4 equations and 4 variables, that's good. Check the units. Delta P is in PSI, and then K times rho is something, wow, what a mess. Dimensionless times kilogram per meter cubed times feet per second squared. Oh, what a mess. Alright, oh yeah, I know the problem. Now, by my own advice, we're supposed to convert this to times convert feet per second to meters per second. All right, that's what I want there. All right, let's check that. 4 equations and 4 variables, that's still good. Check my units. Still, I know why. PSI. I don't want it in PSI. Well, I do want it in PSI, but the problem is I want to work in SI units. All right, so I know how to fix that. So I'm going to go here, and I want the delta pressure that I calculate. Actually, the standard unit of pressure in SI units is a Pascal. Okay, let's try that. Check that. Still 4 equations and 4 variables. And I'm going to check my units. No unit problems are detected. That's fantastic. All right, and then so I'll solve that. And I get, let's see, what do I have here? Delta P is 2007 pascals. Okay, and all that stuff. All right, except the problem is I wanted this in PSI because the engineer, the mechanical engineer, like the plumbing engineer that asked me about this, works in PSI. So I'm going to put that as an alternate unit, PSI, and ultimately that's what I'm interested in. So I'm going to make that a key variable, is that, and we'll call that pressure loss in elbow. Okay, and so that is 2007 pascals, which doesn't mean much to most mechanical contractors, so 0.291 psi. All right, there we go. So now I've converted all my units into SI units. I did all the calculations in SI, but then I displayed it in an alternate unit by right-clicking on that. Furthermore, key variables, yeah, I defined that as a key variable somewhere too. Yeah, so that's all I really need to know. Very good.